In this video, we will be discussing arithmetic sequences and series. This begins on page 802 of your textbook. So an arithmetic sequence has the difference of consecutive terms constant. Therefore, if I take my first term, my second term, and I subtract them, it would be the same difference between the second term and third term, and the fourth term, fourth and fifth. I am constantly adding the same number, or I'm subtracting the same number from term to term. And that number is called the common difference, which will be symbolized by a D. Common difference, symbolized by a D. So let us first look at a couple of examples to see whether a sequence is arithmetic or not. So I need to be looking out for a common difference to see if I'm adding or subtracting a constant. So in order to get from -4 to a +1, I need to be adding 5. Alright, and 1 to 6, adding 5 again, and I need to look at every single one of these differences in terms. Alright, so that means here my common difference is 5, so it is arithmetic. Check. Alright, so from my first to my second term, my second sequence, I'm adding 2, then I'm adding 4, then I'm adding 6, then I am adding 8. Now, yes, there is a pattern, however, it is not arithmetic. It is not arithmetic, and therefore I don't have a common difference. Now, we do have a general formula in order to write rules, so we don't have to go in blind here and just guess whether I'm adding or multiplying. It will say that it's arithmetic, and we will constantly be using this rule. A sub n equals a sub 1, so that's my first term, plus parentheses n minus 1 times the common difference. So they're going to give me a couple of different pieces, and I should be able to write the rule. So let's look at a couple of examples. In this example, we first want to write a rule, and then they want me to find the 15th term. So let's start out by using our formula. A sub n equals a sub 1. Here is a sub 1, that is my first term, plus n minus 1. We don't quite know the n's. And then my common difference. Let's see here. I add 5, add 5, add 5. So my common difference is a +5. Alright, and that is enough information to actually write my rule. So I want to go ahead and distribute here and get 5n minus 5. And here is my rule, 5n minus 1. This is my final rule. So I can now find my 15th term by plugging in a 15. Equals 5 times 15 minus 1, which is equal to 74. Alright, so a sub 15 equals 74. Answering our question fully, I need both parts, the rule and a sub 15. We may come across examples where our common difference is negative. So using relatively the same example here, I just want to go ahead and just plug in some numbers so that you see the difference in what you should do. So let's say instead of the common difference being a +5, let's say I subtracted 5 every single time. So d equals -5. Make sure you put that in parentheses, otherwise our order of operations is going to change, and it will change the answer. These two are not equal, so make sure you put that -5 in parentheses and distribute it properly. In another example, we want to look at if they give us different pieces of information. So let's just say they give me a random term. A sub 19 equals 48, and they go ahead and give me the common difference is 3. So into my formula, I want to go ahead and put information that I do know. So I will put a 3 here, And I don't know my first term, so this will still remain an a sub 1. However, I do know an input and an output. So an output here, a sub 19, it equals 48. And if it's a sub 19, that means 19 was my input. Alright, so I will end up with 48 equals a sub 1 plus 18 times 3. And I will end up with an a sub 1 equals negative 6, since I only have one term to solve for. Therefore, I multiply these and then subtract it to the other side. So now that I have a sub 1, I can go ahead and write my rule. A sub n equals negative 6 plus n minus 1 times the common difference of 3. And then I can distribute that and find my rule, and find any term from that point forward that they ask for. In my last example, it is a little bit of a longer process. However, it's using some knowledge that we have previously utilized in earlier chapters. So if they give you different pieces of information, just two terms. They give you two terms. A sub 8 equals 21 and a sub 27 equals 97. They don't give you a common difference, but they do give you these terms. Here's what we are to do. So I use my formula yet again and fill in pieces that I know. So I can plug in a 21 equals a sub 1, I do not know that, plus 8 minus 1 times d. So that's 21 equals a sub 1 plus 7d. Alright, that doesn't get me very far, so let's see if I can do anything with this next term. So 97 equals a sub 1 plus 27 minus 1 times d. 97 equals a sub 1 plus 26d. Alright, I have two equations and two variables now, which means I can use a system of linear equations. So I'm going to go ahead and line them up vertically. I'm just going to move this one over here and subtract it. So this is a negative 21 minus a sub 1 minus 7d. And I will get 76 equals, these two will cancel out, 19d, therefore d equals 4. Alright, now using the common difference as 4, I can plug that back into either equations. I'll just go with the one with lower numbers. 21 equals a sub 1 plus 28. A sub 1 equals negative 7. Now, I can finally create my rule with these two pieces of information. So a sub n equals negative 7 plus n minus 1 times 4. Negative 7 plus 4n minus 4. And that's 4n minus 11, a sub n. Now I can find any term that they ask for. This one is the most work of all the examples, depending on the specific pieces of information that they give you. Just keep your options open and refer back to your notes. Moving on to a sum of a finite arithmetic series. So with arithmetic series, we do have this formula. So, here we go. S sub n. Why do they use S? Because we're talking about sums and series. Equals n times a sub 1 plus a sub n over 2. Alright, in order to find the whole sum, this is a shortcut. We, of course, could find every single term that they are asking for and add them together. This is just a shortcut. So let's look at this example. First, it would benefit us to go ahead and identify the parts that we need. So first we need our first term, and then our final term, and our final input number. So our final input, n, equals 20. So I need to find a sub 20, and I also need to find a sub 1. So if I find a sub 1, That's going to be 3 plus 5 times 1, and that equals 8. And then if I find a sub 20, that is 3 plus 5 times 20, or 103. Alright, now I can use my formula. So if I were to actually compute all of these, I could plug in 1, 2, 3, 4, 5, 6, all the way up to 20, and add all those terms together. This is a shortcut. So n is 20, then I have a sub 1 is 8, plus a sub n, 103, divided by 2. And if I do 20 divided by 2, that is 10 times 111, or this is 1110. And I should have actually replaced that n with s sub 20 because I am finding the sum of 20 terms.